Great. I think we're live on both Facebook and YouTube now. Okay, well, with that, let's just go ahead and get started. Hi, everybody. Welcome to the official collaboration we're making with MATHCOUNTS. We're doing a state competition live solve, and I'm joined today by two incredible co-hosts, Eddie and Audrey.
Hello.
Yes. Awesome. And both of them actually did MATHCOUNTS before. They actually both had made it into the top 4 of their states, and they were both at nationals. But actually, that's not the most important part. The most important part is we're all here to have some fun doing math. You may already have noticed, actually, that it's possible on the system that we're using to make your comments go onto the screen. So the secret way to do that is to just make sure that whenever you're sending a message, you send it to the user called Chat Relay. And you can see that when you go into the Zoom chat drop-down menu. If you can just put something into the chat relay called, like, you know, what you thought of this year's MATHCOUNTS, that would be awesome. Then we can have some fun. A lot of us are fans of MATHCOUNTS. So just go ahead, that way people can get used to the system. And Eddie and Audrey had already explained to you how this thing worked right when we were getting in and getting started. Okay, so this is all working. Aha, we agree. We also think MATHCOUNTS is amazing, and it's a particular pleasure to collaborate with them, because MATHCOUNTS is actually also what definitely got me interested in math way back in the beginning. All right. Well, with that, let's go ahead and get started. I want to emphasize that the problems that we're doing today, these are problems that are officially copyrighted by MATHCOUNTS. So you're not supposed to actually just throw all of these on the internet. We're doing this because we're officially collaborating with them, and we're very proud to do that. All right. And with that, we're going to go ahead and attempt to solve some of these questions. We actually haven't looked at these questions ahead of time, so we might have some trouble. And if we do, please give us a hand. I'll go ahead and start first, and then I guess after that, maybe let's go in the order, like myself, and then Audrey, and then Eddie. Does this sound good? Yes? Okay, let's try. All right, here's the first question. What is the slope of the line containing the points 3, 4, and 5, 12? So since this is the state live solve, we're going to go a little bit faster. I'm actually not going to draw the line. The way that this works is you will just take the second y coordinate, which is the 12, minus the first y coordinate, which is the 4, divided by the second x coordinate, which is a 5, minus the first x coordinate, which is a 3. So then if I do this subtraction and division, I think I get 8/2. I'm getting 4. I hope this is right.
Yep, chat agrees. I see Emma has a formula in chat as well, which is great.
Yep.
All right.
Cool. Interesting. They chose 3, 4, and 5, 12 because Pythagorean triples.
Oh my gosh, I totally missed that.
Yes.
Anyway, okay. Number 2. This chart shows the weather conditions in Madison, Wisconsin from January 11th through January 15th. What was the mean high temperature for those 5 days in Madison? And express your answer as a decimal to the nearest tenth. Okay, so I'm going to just pull up the chart. That's not much bigger. Okay, I'm going to go back here. So they're asking for the mean, which is just the total over how many elements there are. So in this case, we would add up the highs. So on Monday, oops. Sorry, just adjusting. Okay, on Monday, the high was 10. On Tuesday, the high was 6, just reading off the table. On Wednesday, it was -3. Thursday, it was -4. And Friday, it was 0. And then to take the mean, we just sum those and then divide by Bumbling Bamboo Tree says, I like this weather. Yeah, pretty cool.
Comments about that. Oh boy. Sorry.
Yeah. We divide by 1, 2, 3, 5. And then that gives us, well, 10 plus 6, 16. Minus 7 is 9/5. And they ask for it as a decimal, which is good because we're not getting a whole number here. So this equals 18/10 or 1.8. So I believe that should be the answer.
Yeah, that's what I'm getting as well. Cool, and chat agrees. Cool. Somebody says that's really hot for a January day, but you won't bet here in Ohio, which is like, pretty, northern, I would say. That was probably pretty representative of like a week in January, and especially the fact that it goes from 10 to -3 in the span of 2 days, also very accurate. I honestly wouldn't be surprised if whoever was writing the problem was looked at the weather that day and said, hey, these are some pretty like staggering numbers. Let's make that into a problem. And that's how it came to be. I wouldn't be surprised. All right. Number 3. Screen in a movie theater measures 33 feet by 27 feet in square yards. What is the area of the movie screen? So it just asks for the area of a rectangle, but it seems a little too easy for state, right? I know it is like the beginning, but there's a catch. It's the fact that we got feet here, but it asks for square yards. So I think for those, just a refresher, 3 feet gives you 1 yard. So for 33 feet, that's the same thing as saying 11 yards. And then if I wanted to do 27 feet, this would give me 9 yards. And so if you multiply 11 by 9, you should be getting 99 yards squared. Another thing I'll point out is, actually, I'll just abbreviate it as YD. The units always check out because you're multiplying yards by yards, you're getting yards squared. So that's one thing. And notice that I divided by 3 twice. Once in the width, once in the length. So if I were to find the area in feet, it would have been 9 times as many square feet. So that's another thing to note. Yeah, so for those of you who are getting 891, that's because you did it in feet, and that's 9 times as much. All right.
Cool. So is it up to me now?
Yep, back to you.
Okay. Whoa, I got a long problem. Okay. A sequence is defined as shown for n equals 3, 4, 5. What will be the first number in this sequence that is not prime? So what exactly is going on? Let me see. So I have, I understand. Okay, so I need to just go and figure out what these numbers are. So let's go and start stuffing these things in. So if I have A3 is equal to A1 plus A2, that's 11 plus 2, which is equal to 13, I think. Okay, so I'm just going to methodically start going through all of these things. So the next one, A4 is equal to A3, which is the 13, plus A2 plus 2, and that is 2 plus 2. I'm always a little bit afraid of doing it wrong, so I just write this out slowly. This is crazy. How can all of these be primes? Primes are rare. So whoever came up with this sequence is very, very creative. But so I get A4, which is the 17, plus, plus A2 plus 4. Okay, if you say so. So A2 is just 2. Okay. What? How many primes are there? So 17 plus 6. Okay, this is good. You know, primes are actually very, very rare. So this is surprising that there are so many primes. So 23 plus, and then we have the same A2, and then plus 6. This is nuts. 31. Okay, then I get the pattern already. You just take the previous one, 31 plus, and then 2 plus 8. What? I'm still at, oh no, I can't add. No, I know how to add. It's 41. Okay, let's keep going. So then the next one, I'll make a new column. So now I have 41 plus 2 plus 10. This person is really creative. 50. I wouldn't say there's a way other than brute force because primes are distributed in a semi-random way. So this is equal to, I just can't believe this is actually still going. 2 plus 14. By the way, if I make a mistake, yell at me. Let's see. So 2 plus 14. Okay, so 16. Wait, are you kidding me? So this is 69. Okay, I guess so. 83 plus 2 plus 16. I have great admiration for this problem now. 85 plus 16. Oh no, is that actually right?
This is wild.
This is wild. This doesn't deserve to be the case.
What?
This is crazy. So 2, because primes are supposed to be randomly distributed. So I know how to add that. Aha, I found it. I think it's 121. Okay, I hope so. Yay! Okay, but I just want to comment. It takes a lot of creativity to make a problem that has this many primes in it because primes are rare. It's not like there's a pattern in the primes.
Yeah, that's really crazy. Okay.
I'm so confused. Somebody asked like in chat, is there a way to do this without brute forcing it? I don't know. I don't think so.
I'm almost positive it's impossible because like primes are semi-randomly distributed. So this is great.
Man.
Yeah, that's a really cool pattern. So that goes on like at least, how many terms was that? Must have been like at least 8.
It's a lot of terms.
Yeah.
I was like, come on, primes are so rare. I was like, I'm gonna be done. I bet it's gonna be at this spot, which is blank, because I was like, that's what often happens. And I just kept going and going and going. I was like, no. Okay, awesome. Audrey, it's yours.
Cool. What is the smallest positive perfect cube divisible by 12? Okay, so for this problem, first thing to do would be to find the prime factorization of 12, which is 2 squared times 3. And then if you think about what it means for a number to be divisible by something, that means there must be at least 2 2's in the prime factorization of whatever number we find, and at least 1 3. Otherwise, it wouldn't be divisible by 12. But the last restriction on this is that it should be a perfect cube. And in a perfect cube, all of the exponents are in the prime factorization will be a multiple of 3. So for a perfect square, we know all of the exponents in the prime factorization are even. And then, so similarly in the perfect cube, you want the exponents to be divisible by 3. So we know it has to be at least 2 to the something times 3 to the something. So here there are at least 2 2's. So we'll put 3 in the exponent because that's the smallest multiple of 3 that's bigger than 2. And we also know that there should be at least 1 3. So we're going to put 3 here as well because that's the smallest number that will make this a perfect cube. And at this point, we could definitely multiply by like some other prime and cube it, but we want the smallest one. So I'm just going to use 2 cubed times 3 cubed as our number. And just looking at the prime factorization, this equals 6 cubed. So it's obviously a perfect cube that satisfies the requirements. So multiplying that gives 6 cubed, which is 216. Is that correct?
Yeah.
Yeah,
I'm
okay.
getting that too.
It's 216.
Alrighty. Number 6. While driving, Carl notices that his odometer reads 25,952 miles, which happens to be a palindrome. Palindrome just means that the number reads the same forwards and backwards. And so he thought that this was pretty rare, but 2.5 hours later, his odometer reads as the next palindrome number of miles. What was Carl's average speed during those 2.5 hours? Okay, so the problem asks for the next palindrome after 25952. So thinking about palindromes, I guess the second number, so that's what the thousands place, always has to be the same as the tens place. And then the 10,000th place always has to be the same as the units digit. For me, I would think, oh, to find the next number, I want the smallest units digit possible. Sorry, well, closest to this one. So I'd add to the units digit. But the problem is to keep it a palindrome, I would have to add to the 10,000s as well, which is way too big. And same thing, if I wanted to add tens, because that's the next smallest thing, I would have to add to the thousandth place to keep it a palindrome. So really, to make sure I have the smallest palindrome, I need to be adding to the 100th place because that's the smallest one I can get without adding to anything in the front. So I'll just keep adding hundreds and saying, well, if the next adding 100 to this gives me 26052, which means I'm going to be at least in the 6,000s. And since 6,000 is the lowest possible thousand I have, I'll probably have to echo that in the tens. And I think just looking at 26062, I imagine this is probably the next palindrome because the only thing I could have changed, yeah, it has to be greater than at least 26,000. Yeah, okay, then I think this is right. So to get from 25,952 to 26,062, I just added 100 and then 10. So you traveled 110 miles. Okay, 110 miles in 2.5 hours. And then to make the math easier, I'll convert 2.5 in a fraction. So if I'm dividing by 5 halves, same thing as multiplying by 2/5. And then I'm getting 44. 22 times 2 should be 44 miles per hour.
That sounds believable.
Yeah, I think that looks right.
Yeah, I don't know. The reason why I paused earlier, because I was like, I thought he would be going faster because it was like on the highway. But I guess he's just like on the local routes, you know.
Actually, that's a great thing you just said, because at first I was like 44 miles per hour. That would make sense, right? Because like I could imagine doing that on some like medium road. But then it's also good that you had the intuition to be like, wait, on the highway you might go an extra 50% on that. So
Yeah.
yes.
44 miles per hour is really, really slow.
Oh my gosh, Bumbling Bamboo Tree has the best comment.
He has a flat tire.
It's a flat tire.
Maybe.
He's doing math counts problems on the clipboard on his phone. Don't do math counts problems and drive at the same time. Okay.
You know who does have a flat tire though? I do. My bike tire went flat and now I'm sad.
Oh
Oh,
no.
Maybe it's because I was doing math problems on my bike. I don't know.
Oh my gosh. Okay, I think I'm the next. Is that right? Oh yes, I have a heart or diamond. I know what diamonds are. Okay. Oh no, somebody's bike stand fell off. We feel for you. Okay, so let's see. So let A diamond B equal AB over A plus B. What's the value of like some bunch of diamonds? Okay, these are kind of fun questions. I just stuffed them in. Actually, it seems like I'm getting the questions that I just stuffed numbers into. So let's see. So 1 diamond 2, that would be 1 times 2. So let's just write it this way. 1 diamond 2 is equal to 1 times 2 divided by 1 plus 2. And so that's just 2/3, I think. Yeah, you'll notice what I'm doing. I'm sort of checking what I'm doing as I do each step, because I remember doing the sprint round before when I was doing math counts. And sometimes I'll be like, oh, let me just do them all fast and then go back and check them all. And it turns out that that doesn't always work, because you don't always manage to do them all fast. So like now I sort of do these problems where I do it and I think as I do each one. Okay, so the next step is to take the 2/3 diamond against 3. So I'm just going to do 2/3 times 3. I can do that because 2/3 times 3 is very nice. It's just 2 divided by 2/3 plus 3. So I'll just write that here as 2/3 plus 3, because I've got to do something with that fraction in the bottom. So it's something over 3. 3/3. Sorry, 3 is 9 over 3, and I take 2 of them plus the 9 over 3, so I get 11/3. And so this is all 6 over 11. Is that right? Yay! Okay, I survived.
Yep.
Audrey, it's you.
Cool. Grapes, nice. Okay, grapes are 80% water by weight. When a bushel of grapes dries in the sun for 2 weeks, it loses half of its total weight. And all of this is due to the loss of water, which makes sense. And then after drying for 2 weeks, what percent of the grapes is water by weight? Cool. So for these kinds of problems, I would honestly just assume 1 to make it easier. We could definitely let X be the weight of the grapes, but in this case, it doesn't really matter. So if the grapes are 80% water, we can say that it's 0.8 water and 0.2, just, I'll call it dry grape. I don't know. And then we know that it loses half of its total weight after 2 weeks. So in this case, because we made the total weight just 1, which is a nice number, we know conveniently it'll just lose half with whatever units. It doesn't really matter. And all of this is due to the water. So we'll end up having 0.3 water and then the same, which is 0.2 dry grapes. And then finally, what percentage of the grapes is water by weight? So that would just be 0.3 over the total, which is 0.5, 0.3 plus 0.2. Again, just actually, yeah, I can just multiply this by 2. So you get 0.6 over 1, which should be 6, wait, going off the page a bit, which should be 60%. And that makes sense because then it'll be less percent water because it's lost some of the water throughout the 2 weeks. So we would expect a number less than 80. So seems reasonable enough.
Wait, it dries
did
for
I?
2 weeks, right? I think it dries for 2 weeks.
When,
Got to do the whole thing twice.
wait. Well, it says
wait.
when it dries for 2 weeks.
Oh,
it
wait.
loses
Okay,
half.
my bad. I didn't read. Oops.
Okay, actually, that
I
would
was
be
like-
really tricky if they say
Yeah,
like
I thought
it
it was-
loses half for 1 week. Okay.
My bad.
Yeah, I believe
This
it
is
is.
really hard.
Yes. I didn't mind. I skipped over it. The only other thing I can think about the problem is like, if you think about water to total grape, because the only weight you're losing is water, like, I don't know, if you want to make a graph of, you know, total grape to water, since you're only losing water, the difference between how much water there is and the total grape is always the same. So because there's 50 grape left, well, I guess there's 50% of grape left. Knowing that the difference is always 20 because it's 20% off the whole grape, then you can easily get 30% and 50, and you get 30 over 50 as well. It's not necessarily faster. It's just another way to think about the same thing. All right.
Ooh, okay, I agree. That is cool.
Yes. All right. Number 9. A is 5 times as large as B. Sum of A and B is 15. What is the value of the product AB? Okay, so because it says the sum of A, B is 15, I think it's like visually, like this is what I see in my head when I'm doing these problems. It's like, I know I have a total 15. And since I can split this into one part, which is B, and something that's 5 times as large, which is 5B, or in other words, A, this is A, but it's also 5B. So A is 5 times as large as B, but they both together, they make up this 15. So as a whole, I have these 6 parts. These 6 parts make up 15, and B is one part of those 6. So B is going to be 15/6, and then that's what, 5 halves, and then A is 5 times as large as that. So A is going to be 25 over 2, 5 times as much. And you multiply those two together, you should just get 5 over 2 times 25 over 2, which gives you 125 over 4. And it just says express your answer as a fraction. So that should be it.
Yep.
Cool.
I do like that way of writing it out with the using it visually versus just jumping in and saying A equals 5B, A plus B equals 15, because I feel like it's faster. The bar model stuff. Yeah, kind of reminds me of a bar model.
Yeah, thanks for sharing that visual. That actually makes it so much easier than even using like algebra or something. Okay.
It also makes it easier to do mental math, I feel like, if you can just be like, okay, bar.
Yeah, awesome. So I guess I'll go next. What's next? Sprint number 10. Oh boy, Goldbach's conjecture. I'm not sure I can prove that. Okay, anyway, it states that every even number greater than 2 can be expressed as the sum of 2 prime numbers. For example, 2022 is 191 plus 1831. How many ordered pairs of prime numbers have a sum of 60? Oh, I got prime questions. Okay, so I think I just need to know about like prime numbers less than 60. So let me go ahead and first just like make some list of prime numbers. I'm going to do it this way. It's 2, 3. Oh, I don't need to worry about the even one, because if I have a pair of prime numbers adding up to an even number, then I'm not going to have to worry about odd plus even, right? It has to be odd plus odd. So I have a 3, I have a 5, I have a 7, I have 11, 13, 17, 19. Somehow I just know how this looks. It's like it's got 4 of them in the first row, 4 in the second row. The next ones are 23 and 29. There's 2 of them there. There's 31, 37. Then the next one has 3 of them. 41, 43, 47. And then in the 50s, we have 53 and 59. Okay, good. So here are all of the primes that I have. I don't need to worry about bigger ones at this point. So the next thing that I'll do is I'm just going to say, how do I make a sum of 60? I'm just going to circle the ones for which I could find a partner which adds up to 60. So for the 3, I can't. Well, I guess I'll also cross out the ones that I can't. So I can't do the 3. The 5 is not going to work. I started thinking, can I use some fancy thing about relative primality? But that might not exactly work because there might be some special cases. So the 7 is going to work. The 7 is going to pair with the 53. The 11, I'm only going to have to go halfway, by the way, because it's symmetric. So the 11, well, that would go with 49. That's not okay. The 13 is going to pair with the 47. They add up to 60. 17 is going to pair up to 43. I like looking at it this way because I can just see them as they match up, the 19 and the 41. And the other way I double check my work is I just know that's the pattern of how these things go across. It's like 4, 4, 2, 2, 3, 2. And then I have the, oh, neat. 23 and 37 match. And 29 matches with 31. There's a whole lot of these. How many ordered pairs have the sum of 60? I'm going to draw a line here, and I'm going to say the number of ordered pairs is just the number of circles, because each of them could be the beginning of the pair. But I could just take the number of circles in the top half and times 2, because they all come in pairs. So I have 1, 2, 3, 4, 5, 6. 6 times 2 is 12. Is that right?
Yep, seems like people are saying 12 as well.
Yay!
Oh, so it's my turn now.
Yeah.
Okay. the function f of x has the property that if p and q are any two distinct points on the graph, then the slope of PQ is twice the sum of the x-coordinates of P and Q. Okay, let's see. So that means if P and Q are any two distinct points. So we can say like P equals x1, y1, and Q equals x2, y2. So slope of PQ, as we found earlier in one of the other problems, is just y1 minus y2 over x1 minus x2. And they're telling us that this is twice the sum of the x coordinates. So that's 2 times x1 plus x2. So that's basically the first sentence of this problem. And now we're trying to find the value of f of 10 minus, f of 10 minus f of 0. So that f of 10 is basically the y value when you plug 10 into the function, and 0 is the y value when you plug in 0, or f of 0 is the y value when you plug in 0 to the function. So really, they're just asking us for y1 minus y2, where x1 equals 10 and x2 equals 0. And conveniently, we can find that just in terms of everything else. So let me just move this. Okay, so the expression that we got is that y1, whoa, what happened to my, okay.
I think it's a highlighter.
Yes, let me change that back. Is this better? Yes, cool. y1 minus y2 equals 2 times x1 plus x2 times x1 minus x2. And then, so we can just plug in 10 and 0. If we let x2 be 0, then this just cancels out. So we get that it equals 2 times 10 times 10, or 200.
Yay, that's right.
Makes
Okay.
sense. All
Cool.
right.
That's actually a pretty cool problem.
That's pretty neat. I'm wondering what the function is. Like, what would it look like? All right, but moving on to number 12 in the meantime. Got stacked cubes. Oh, I feel like MathCounts love stacked cubes. I feel like I've seen this setup a lot of times. Okay, what is the surface area of the figure? Okay, I feel like surface area and stacked cubes also come along quite well. All right, so the trick here is like, you might be tempted to be like, all right, so for the bottom cube, for example, the top, only this area is exposed. I need to find the area of the sides and then get only that section of the top. But here's the thing. If you notice, like if I have a cube, this is weirdly drawn. This is a horrible cube, I'm sorry. But if I put something on top of it, so like this is the area of the top face. If I put something on top of it, what's going to happen is, even though what used to be the top face over here got covered, now it's just the top, it's the same area as the top face of this cube. So really, the area of the top face is still the same. It's just now that this part is covered, it just moved up. And so this is what happened, but another time. So what was originally like what, this section of the 3 cube that got cut off, now it's just the 2 cube, the top face of that cube. And then that got cut off and now it's the top face of the first cube. So really, if you go look at it from a bird's eye view, it still looks like a 3 by 3 square. So the area of just the top is still going to be a 3 by 3 square, which means I'm just going to find the surface area from all sides. So the top face is going to be a 3 by 3 square. So that's going to be 9 centimeters squared. And then same concept from the bottom, although bottom is definitely easier because there's no like stacking or overlapping. So bottom is also 9 centimeters squared as well. And then it looks like it would be the same from the left front, all the other 4 sides, right? Because it's just the 3 by 3 square and then a 2 by 2 square, then a 1 by 1 square on all 4 sides, right? So for the other 4, I'm also getting a 1 by 1 squared and a 2 by 2 squared and a 3 by 3 squared. That's 1 squared plus 2 squared plus 3 squared, which should give me 14. And so I'm getting 14 sides. I'm getting 4 sides of 14 centimeters squared. So multiply this by 4. Should be getting a total of 18 and 56. So 18 plus 56 gives me what, 74? Did I do that right?
Yes.
I'm getting, okay,
Yeah.
74 centimeters squared. Cool.
Okay. Actually, I'm going to do something that I'm not supposed to do. We were supposed to go through these problems, and it's supposed to be my turn. But I want to go back to this one that, Eddie asked a really good question that just got me thinking. It's like, what is this graph anyway, right? So I want to answer that, and then after that, we'll continue on with Audrey. But at that point, we might start going backwards from question 30 just for some variety. But I just want to say something here, which is probably way out of scope of math counts, where probably is definitely. But it's just that somehow, if you're talking about the slope between any two distinct points. Well, what if I chose two distinct points that are really, really close to each other? Okay, so this is actually an instantaneous slope fact. Now that's a concept from calculus. You need to ask Newton for more details about that one. But effectively what this is saying is that it's saying that I've got some curve, like some weird curve or something. And if I take this weird curve and I take 2 points which are really, really close to each other, see, those are really close. Then somehow the slope, this is going to look terrible, but the slope of the line that goes through them happens to be twice the sum of their x coordinates. But at this point, since they're really, really close together, their x coordinates are both like, well, they're both basically x, right? So what I've got here is that the slope of f at x is 2x. Okay, so this is actually a concept called a derivative, which is, again, way beyond the scope of math counts. But this is telling me that the derivative of this function is f prime equals 2x. It looks really it looks like a really confusing line connected to a parabola because it is going to be a parabola. Because this is something where the instantaneous slope is 2x. And if you take a class in calculus, what does derivative mean? Derivative just means that's like the instantaneous slope. And what you'll learn in high school is you'll learn that if that's the case, then f of x is going to be x squared plus a constant, where the constant could be anything. It could be x squared plus 50, it could be x squared plus 1,000,000, it could be x squared minus 200. But now the question asks for f10 minus f0, and then the plus c cancels out. So now the plus c cancels out. So if I actually wanted to do this, and I'm going to run into my head or something, but if I want f10 minus f0, then that's just going to be the 10 squared minus the 0 squared, because the plus c's cancel. It's 10 squared plus c minus the 0 squared plus c. So that's 100. By the way, this is slower than what Audrey did. But this is just that I got curious because Eddie asked, like, what is this? So it's a parabola.
Yeah, it's pretty cool. I think also if you were to sort of visualize it that way, because Professor Loh says it's a parabola, so you can just let the vertex be 0, 0, I think. So then you know when x equals 10, the slope is twice that, so it's 20. And then just to find the value of f of 10 minus f of 0, it would just be 10 times 20 or 200. Cool. So should I go to number 30 now?
Why don't you jump to 30 and go backwards?
I think it's really interesting that like expands to all coordinates as well, like it just any two distinct points and not just like instantaneous ones.
Yeah.
Interesting.
Okay. Number 30. Draw and insert some number of parentheses into the expression shown to create a valid mathematical expression. And we want to minimize, but it has to be an integer. So what is the smallest possible integer value? Okay, so that's kind of annoying because otherwise we could have just tried to make it like 1 over a very big number, but the constraint that it's an integer makes it a bit harder. So let me see, 1 over 2. So for example, we could like put parentheses here or wherever we wanted. And actually, this is kind of equivalent to, we can take the numbers 1 through 10 and either multiply them or divide them out. So for 1, obviously, you're just going to multiply. But for 2, if we wanted to divide it, we would just not put any parentheses here and then like maybe add some parentheses to the right, depending on what we wanted it to be. But if we wanted the 2 to be multiplied, we would, oh wait, does that work? I feel like, okay,
this
that
is
might
really
not
clever.
work.
So I was just typing in our internal chat, this is a mess, but this might work.
It might, okay. I'm not sure because I think I talked myself out of it. But my initial thought was to sort of think about the smallest integer you could get when you cancel everything out, basically. So if we multiply the numbers 1 through 10 and then try to divide out the biggest number we can to get an integer, I think that might work. So I guess I would write like the prime factorizations of each. So we have 2, we have 3, 4 squared is 2 squared, 5 is 5, 6 is 2 times 3, 7 is 7, 8 is 2 cubed, and 9 is 3 squared, 10 is 2 times 5. So right off the bat, the 7's definitely going to be in the numerator of the big expression because there's no other 7. And if it were in the denominator, it wouldn't be an integer. So the next question would just be like if the rest of this can cancel out, or if not, yeah, maybe think about a theoretical minimum. So right now that would potentially be 7. I'm just trying to see like, so for example, we could put 5 in the numerator, just arbitrarily, and then 10 has to be in the denominator. Let me just make that 2 times 5 because we want the 5s to cancel out. So that's done. And then 3 squared, the 3's we might deal with separately. If we put 3 squared somewhere, we want 2 times 3 and 2 to be in the same spot. Oh, or 2 squared. This is interesting. What do you think? Wait, actually, I probably could just count up the number of 2's there are. Like, for example, oops. For example, there's 1, 2, 3, 4, 5, 6, 7. There's 8 2's. 1, 2, 3, 4. There's 4 3's, and there's 2 5's. So since there's an even number of each, there could potentially be a way for us to like put them, rearrange them so that they will all cancel out and we get 7. And if I were just taking this test, I would just put 7 there and move on and not try to find the exact way. This isn't exactly like the most rigorous though, so I'm not sure.
Yeah, let's work together on this one. This is actually pretty interesting. Yeah. I'm just playing around. I'm being inspired by your ideas of like, let me see if they can balance around. And I haven't solved it yet either. I'm just trying to be like, okay, I got all these things and I'm now using trial and error to try to balance like my yellow ones against my blue ones, my green ones. I also really like what you said. I think you do have the power to go and flip these things around to be on either the top or the bottom of the fraction, except that 2 is forced to be on the bottom. It's because like you'll do 1/2, and if you want like, it's like, do you want the 3 on the same part of the 2 or not? If you want the 3, oh wait, no, now I'm confused. Now I confused myself too. Hang on a second.
No, I got that too. You can definitely make it after the 2. You can make it whatever you want.
How do you do that?
Because like if you want like if you want 3 to be on the bottom, you can do that, and then you just keep doing parentheses. Like now 4 is on the bottom as well. 5 is on the bottom.
Okay.
I think right.
Neat. Oh, I missed that.
And you just keep nesting with the left.
Okay, so you can nest with the left to go and make things go on the bottom. How do you make something flip back onto the top? By just like not nesting it. That seems like the first step of the question, right? So
I
like,
think it would, yeah, you do like another one over here,
right?
Something like that. Yeah.
Let's just do a random case together because now I'm interested. It's like, can we make something where the 5, 6, and 7 are on the bottom and everything else is on the top? Sorry, the 2 is always on the bottom. So I'm just like, can we solve that? If we can do that, then I'll believe that, you know, you can always make the 2 is always on the bottom and you can do whatever you want with the rest. But how would you do it so that the 5, 6, and 7 are on the bottom together with the 2 and everything else is on top?
Wait, so the 5 and 6 are on the bottom.
At the bottom.
I want 5, 6, and 7 all on the bottom with the 2.
All on the bottom. And then, so to get 3 on the top, I would have to do this. And then 3 to 4 together, you do that. So I now have 3 together and I divided twice. So now 3 and 4 on the top. And then divide by 5, 6, and 7. Divide by, wait, so I want to divide by 5. Then I divide by 6, so I nest that.
But something's not great because the 3 and the 4 are currently on opposite sides in your thing. Because there's a 3 divide 4. This might work, but like I'm just like, how do we do that exactly?
And you'd have to do like 2 divided by 3, nest that, and then divide that by 4.
That seems believable. Actually, now it seems like it seems like what we want is if the things are supposed to be on the same side, then we can't have a divide by sign survive between them. Is that how it works?
So
Yeah, go on, Audrey.
one thing I found, like if we do play around with it trying to balance it out, I think if you do 7 times 8 times 9 times 10 over 1 times 2 times 3 times 4 times 5 times 6, that should work. I don't know if like, it's interesting that they're consecutive on both the numerator and denominator. So I'm not sure if that has to do with why it might be possible.
That's just so cool. I mean, this strikes me as another one of these random things where the primes all worked out. But like, are you saying that all just cancels out to just a straight 7?
Whoa.
It could be if we could potentially write it like that.
Now let's do it.
Yeah.
Okay. Eddie, can you
wait.
do it? Do you think
All
we
right,
can?
so 1 divided by 2, 2 is on the bottom. 3 is on the bottom now. And then 4 is on the bottom.
Oh, yeah.
And then 5 is on the bottom. 6 is on the bottom. Okay, and now the issue is getting the rest on the top. So I need to get 7 on top, which means I'm going to undo the last one right there and make it so I'm dividing by 6. And so what I need to end up getting this to look like is I need the 6 to look like, I need the right hand side to look like 6 over 7 times 8 times 10. Because that way, if I divide by that, the 6 is on the bottom, everything else flips on top. So if I nest the 6, then it's just the same thing where we nest every parenthesis from there, I think. So 6 divided by 7 divided by 8. Yeah, I think this is it. Divided by 9 divided by 10, right?
Oh my gosh, this actually does work.
Wow.
That is indeed some number of parentheses. Oh,
Wow.
boy.
Okay, is that the answer? So is the answer then 7? Is that what we're saying?
I don't think you can get anything
Oh, it
lower
is
than that.
7. Yeah.
Nice.
I think I
Wow.
just checked.
So first of all, this shows. Oh, go on. Audrey, go on.
No, I was just saying that's crazy how you can just write it like that. Very coincidental.
Yeah. And it also shows that, Audrey, your instinct to just go for the 7, that actually worked. But it's also really interesting because, like, I think each of us multiple of us started convincing ourselves and unconvincing ourselves that it was possible to just like arbitrarily flip the numbers around. But this is cool. Okay.
Huh. I guess what we can learn from this, I think I just noticed, is like 7 times 8 times 9 times 10 is the same thing as 7 factorial. I feel like I've heard that somewhere, but like I guess this just proves it. Like it just happens to work this way, which is why when you take, oh wait, yeah, because 8 times 9 times 10 is 6 factorial. That's why. So just this part is 6 factorial. So I guess that's maybe it'll be useful, but I guess it's like, I don't know, intuition or something.
Actually,
All right.
I think I heard that from an old math counts problem.
Oh, really?
I think it was an old math counts problem.
Full circle. Oh boy. All right. Number 29 then, right? Because we're going backwards. Is it my turn? It is my turn, right? Okay.
Yeah.
Yep.
All right. So we're writing all of this out and seeing what digits it's in the hundredths place. So this sounds like number theory. And when I'm thinking hundredths place, we're looking for whatever number's in there, which means it's technically mod 1000, right? That's like my first instinct. So basically, if we divide it by 1000, what number are we gonna get? And then we just take the hundreds. But I don't know. Let's take a look at this and see what happens. Oh, wait, sorry. It says a decimal. I'm very dumb. Hundreds, not hundreds. I can't read. All right. So that means we're looking for something over 100. Sorry. We're technically subtracting squares here. So that's another thing to look at. This is interesting.
I think it looks like
guess
it's close to 1.
Oh, that's true because, oh, okay. 11 to the 20th, because we're multiplying this so many times, like if you can just imagine the difference between like what's a good example? Like 8 cubed and 10 cubed are already like, this is 1/2 of the other. So if you can imagine, if I take these two numbers, which again, roughly the same distance, but I take that to the 20th power, they're going to be off by a huge margin. And so the adding 9 to the 20th to 11 to the 20th isn't going to change the number much. 11 to the 20th is going to be, I don't know, however many digits. And then adding 9 to the 20th is only going to be like adding some number here, not as many digits. So really, if the 9 to the 20th doesn't affect that much, we can round it. I guess we could say round to 11 to the 20th. And so it is awfully close to 1 because whatever we're adding and subtracting, this 9 to the 20th, it isn't that much. So that means this is going to be roughly 1. And the thing is, it's going to be 1 point something, but because it's so close, it's very unlikely, just looking at this estimate, it's very unlikely that there's going to be some difference, some margin past the hundreds of it. If there is a difference, it's going to be way past, maybe in like, I don't know, the millionth place. So we can be pretty safe saying that it's 0.
That would be my guess. Is it?
Oh no.
It's not
Oh,
0.
no.
Unfortunate. All right, let's try that one again. Uh-oh. Man, okay, so, okay, I think this reminds me of like, you know, those problems where they're like, can you find something like 2002 to the 1001 over like 2 to the 7 minus 1, something like that, and it like divides. Oh wait, no, that's 1120 plus 920. This is interesting. I guess the number is what? I guess you can think of it as like the numerator is 11 to the 20 minus 9 to the 20th plus 9 to the 20th plus 9 to the 20th over that whole thing. And so that way, the difference is going to be 2 times 9 to the 20th over 11 to the 20th. This is hard to see. This is going to be 2 times 9 to the 20th over 11 to the 20th minus 9 to the 20th. And then from there, now we're just guessing what is this difference? How much of a difference does this make? So this is already 1, and it's 1 plus this. Let's think about it.
I have a random idea which might not work, but I think that is that what you're doing already? I'm like, sometimes when you have these fractions, if you add the same thing to the numerator and denominator, it doesn't change it by too much.
I feel like, what if we compare it to like, you know, stuff like 1 over 100? Because like if this is 100, then it would have to, I'm trying to figure out like a good way to gauge the differences between 11 to the 20th and 9 to the 20th.
Yeah, I think that was actually my first thought for this, because if you compare it to 1 over 100, 100 is 10 squared. So that's sort of close to 11. So maybe if you like multiply the inequality, it would show something.
Yeah. So like, I mean, if we okay, is it more than 100 question mark? Well, if we multiply it out, it's going to be 200 times 9 to the 20th is greater than question mark 11 to the 20th minus 9 to the 20th. The problem is you can't factor anything here. They don't have any common factors. That's why I was hesitating, because it just doesn't, I don't know how we tackle that. Maybe what we can do, actually, yes, I have an idea. So we add 9 to the 20th onto the other side. We're asking, is this greater than 11 to the 20th? And here we can factor 9 to the 20th out. This is 200 plus 1. Because then I'm guessing, is 201 greater than 11 over 9 to the 20th? This is the question. And I think from here, I think we maybe, I don't know if you guys have any other ideas, but what if we start estimating? Like, I know 11 cubed is 131, and 9 cubed is 729. And this is like a little more than a half, right? So this is greater than, so I guess this would be like what? I'm guessing like 1.8. This is the difference. So if in the cubes, actually, let's do the 4th power. The 4th power might give me better results. And 4th power is also 4 is a factor of 20. So that's also what I'm looking at.
Ooh,
so
I want to give an idea. I just saw that 9 over 11 is like 81 over 99. So it's like 0.818181. That's very close to 4/5. Does that help?
Ooh. So
Maybe not. Actually, no, sorry, your thing is just as good.
I think
Your thing is
maybe
better.
with forfeits, I feel like because that's a first power, like with a fourth
Yeah, it's
power,
gonna make
it's
it
like
worse.
already
You're
like
right.
somewhere closer. So 8, 2 times 9, 265. So it's 9 to the fourth power is 6561. So if I know that 11 to the fourth is 14641 from Pascal's triangle, and the 9 to the fourth is 6561. Okay, so 9 to the fourth over 11 to the fourth is actually less than 1/2, which means 11 over, okay, so I should probably reverse that. 11 to the fourth over 9 to the fourth is indeed greater than 2, which means if I raise this to the fifth power, because in order for me to raise 11 over 9 to the fourth to the fifth power, wait, I need to take this to the fifth power to get to the 20th power, which means this is going to be roughly 32, probably more than 32, right? So that means this is true. It is greater than 1 over 100, okay? The problem is now, how do we know exactly how much to go? Because what we just did is we cross multiplied here. I put a random number 1 over 100, but now we're guessing how many hundreds, right? What number is in the hundredth place? So if I put an X there, then I would be multiplying. I see.
Your thing is still pretty good, by the way, because if you got 32, like 1 over 32 is around 0.03. The answer was like 0.03. So
wait, it's just wait, why is it 1 over?
Oh, maybe it's not 1 over 32. You did the fifth power of that thing, right?
Yeah, no, I did the fourth power.
This is crazy.
Oh wait, wait. Okay, because I'm gonna rewrite what we just had there. So we were just saying 2 times 9 to the 20th over 11 20th minus 9 20th, and we're like, all right. So we need to figure out what's the largest X that's greater than, because it's gonna give me like 100th plus something. So X is gonna be our answer. That's the hundredths place. And this is going to be over denominator 100. So if I multiply this through, this is 200 times 9 to the 20th is greater than, and then we multiply out. So 11 to the 20th times, I don't know what I'm doing with my colors, times X minus 9 to the 20th times X. And what I did was factor out the 920. So let's move the 920 terms over. 200 times 9 to the 20th plus 9 to the 20th times X is greater than 11 to the 20th times X. And then if you factor out a 920, 9 to the 20th is greater than 200 plus X is greater than 11 to the 20th times X. Okay, and then what we just discovered is that from here, 11 over 9 to the 20th is roughly 32. Maybe, but keep in mind that it's a little more than 32 because that was our estimate. So if I divide both sides by 9 to the 20th, I get 200 plus X is greater than 11 to the 20th over 9 to the 20th. And we just discovered that that's roughly 32. I'm going to put approximately, just to make sure we know as a no, times X. But that means it would be a lot greater than 3. Do we just keep going for more accurate approximations?
Hey, does anyone in the chat have ideas? You need to save us.
Oh no.
These are hard.
I
Man.
saw a lot of people saying, I use the calculator, but unfortunately that's not allowed.
So there's something I'm a little curious about. If anyone here is with a calculator, I have this approximation here. How close is that? Like, does anyone know what this is? 2 times 9 to the 20th over 11 to the 20th? Like, what is that actually as a decimal? Because I'm just like, if that is like close to 0.03, that would be useful.
Yeah, it's 0.0361.
Okay.
0361. Okay.
So it's like we need to approximate that thing. That's basically what this is. We need to know what that thing is. Because like this approximation is pretty good, because what I just did here is I just like added a tiny amount to both the top and the bottom. That doesn't change you much at all, especially when the fractions are really big. And so then it's like, how do you get this thing? But at that point, like if I really had to brute force it, I might end up doing something like repeated squaring. It's like if I needed to do something to the 20th power, you don't have to multiply it by itself 20 times. You can square it 4 times, but that's still painful. So I don't have a great answer here. Yeah.
Especially given the time restriction.
Yeah, given the time restriction, I don't know how anyone can get this question. So I think I'll have to say, let's go on to the next one, and we'll leave this as an exercise to all of the future viewers of this video. See if you can find a good way to do this.
Wait.
Oh, you got it?
I think so. Okay.
Oh, there you go.
So this is still using the approximation that 11 to the 20th over 9 to the 20th is roughly 32, right? So
Yeah.
if I say this is roughly 1 over x, I'm going to get that x has to be roughly 16, and 1 over 16 is 0.3125. Wait.
Oh, it is.
0.3125. Wait, am I? No. Am I doing this right?
Actually, I think you're
No.
right.
That's 1 over 32.
No, there should be a
right?
6. There should be a 6. There should be a 6 involved because 1 over 32 is going to give you 0.03.
Oh, wait, hold up. If 1/8 is 1.2, then this is 0.6. Right, this is 0.62. Wait, yeah, this is 0.62. Wait,
Yeah.
no, that's not right.
Because 16 times 6 is 96, I think. Is that right?
Yes.
Yeah.
Uh-oh.
It's okay. Let's leave this one just because it seems like it ends up being a complicated thing where we have to approximate this, and none of us are able to see it right now. But it's okay. If you're watching this video in the future, leave a comment in the YouTube chat, and then we'll all know. I think let's just finish up one more question. I owe the team to do one of these hard questions, so I'm going to try to do it. Okay, so just a second. I don't want to reveal the answer, so let me just keep going. Okay, so where are we? I'm going to attempt to look at number 28. Oh, Patrick Tang says the answer is incorrect. It is 0. I'm not sure I believe that because we just checked this. And so I think we're good with the 3. Just because with this other approximation, we typed in 0.03. But maybe if Patrick is right, somebody in the future will watch this, leave it in the chat and we'll see. Okay, the quadratic polynomial p of x is equal to ax squared plus bx plus c has positive integer coefficients, a, b, and c, that each have a value from 1 to 9 inclusive. To 8 decimal places. Oh no.
Oh, decimals today.
Decimals. Oh no. The solutions are x equals minus point this thing and x equals minus point that thing. Oh, but it's a quadratic polynomial. Okay. It has positive integer coefficients that have a value from 1 to 9 inclusive. Okay. What is the value of p10? What? Okay. Let's see. Let's play with this. And by the way, unfortunately, our time is going to be such that this is the last problem that we do. So Audrey and Eddie, if you have ideas, you can jump in and interrupt me.
I mean, because it says positive integer coefficients, I feel like you just you add them, roughly estimate, and hope you get a close to a nice fraction, and then you get coefficients for Vietas, right?
Yeah, maybe. Yeah. I see. There's coefficients for Vietas. So maybe let's start with that. Like the sum of the roots is actually going to be nice, right? Because the sum of the roots, what's the formula? Anyone in the chat, you can type this too. What's the sum of the roots in terms of the b and the a? Does anyone know? It's minus something, right? Is this right? Minus b over a? Minus b over c? No? I think, oh yeah, that was a typo. Minus b over a. Good. And this is like a nice number because these are numbers from 1 to 9. Okay, what's the sum of those roots? Well, at least they're both negative. Minus 1 point.
It looks awfully close to -3/2.
Oh, that's so close to -3/2. Okay, thanks, team. Okay, so now what? So now we know that the ratio of b to a is 3:2, but it could be 3:2, it could be 6:4, it could be 9:3. No, 9:6. Okay. Oh, now let's do the product of the roots, I guess. Oh. Okay, let's try. What's the product of the roots? Well, that's supposed to be c over a. Is that right, guys? Okay, thanks, team. And I also see it in the chat. What's that? 0.19 is close to 1/5. Go on.
Yeah, I think
see it?
I was gonna say it's close to 1/5, but there's another hint, and it says each of them has to be a value from 1 to 9. So I'm like,
yes,
that would narrow down the search a lot.
Yeah. But I'm just like, the x is close to minus 1/5. So if I'm going to try it, I'm just going to first say it's going to be close to the minus times minus is a plus. It's like close to 1.31 times 1/5. Is that a nice number?
I think,
I estimated.
well, actually,
2.6? Oh, yeah.
yeah, if you approximate them as 19 over 100 and 13 over 10, that's pretty close to 250 over 1000, which is 1/4. So
Oh,
it might
that
be
looks
a
good.
quarter.
Yeah, that looks good because the way I'm doing this is I multiply by 1/5. I multiply by 1/5 by doubling it and dividing by 10. So that would give me 0.0, what did I do? No, 0.262, right? So that's, I believe you're 1/4. I think it's about a quarter. Can we finish it from here?
And that works out nicely since the denominator of the sum is 2.
Okay. But if the denominator of the sum is 2 and the product is c over a, then what's a?
This would be 4, right?
Oh yeah, okay, of course that works.
Big.
Yes. Thanks, guys. That looks promising. Okay, I'm glad I have a team here. So I have like a is equal to 4, c is equal to 1. Let's put b in the middle. B is equal to, is it 6? And c is equal to 1? Is this what we think?
Yeah, that looks right.
That looks good.
Okay,
There
let's try
definitely
putting it
aren't
in.
any others.
Okay, let's try putting it in then. So in that case, what we have is we have ax squared, which is, 100. Oh, that's nice. I like plugging in 10. Plugging in 10 and a polynomial, if all of them are single digit numbers, that's very nice because it's just like place value. Is that the answer?
Yes, it is.
We did it. Okay.
That's nice.
So in this case, actually having lots of decimals was nice because then we could see
Yeah.
stuff.
I think knowing that we could approximate this as 1/4 was nice because since the sum said the value of the sum was 3/2, we know that a is a multiple of 2. But if this had something else in the denominator, like for example, 2/7 is 0.28, which is pretty close. But if 2/7 was the denominator, that means a would need both a factor of 7 and 2. But that's 14, and it says only digits from 1 to 9. So I like using this, we're pretty confident that the only thing close enough to 0.26 that wouldn't blow up a would have to be 1/4. And so that also confirms that the answer is 640
Yeah.
as well.
So this is good stuff. Well, with that, unfortunately, this hour is over. I want to say thank you very much to MathCounts for making these really interesting questions. Thank you to my co-hosts, Audrey and Eddie, for coming here tonight, or today, depends on what time it is for you guys. We're going to continue this with 2 other co-hosts on Wednesday. Actually, I don't know if you could tell, but I'm doing this live stream right now from Hungary. Apparently, the internet still survived this entire hour that I was going, running this entire live stream through my phone. But in any case, we will have another pair of amazing high school students to join on Wednesday. And congratulations to all of you for working on all of these problems. All right. Well, with that, I'll stop all of the live streams. And we might be here in this room to like chat very briefly, but we'll otherwise also close out. So goodbye, YouTube. And